Hello. So I'll be talking about potential divider. So we had already studied this potential divider in AS, but we have less concept about this potential divider in A2. Actually, what happened to many students that most of the students start forgetting what they study in AS. So here I'll only describe about the actual concept of potential divider. So how it works. So what is the work of potential divider? How it gets function. So this is a simple diagram of potential divider. So you can also add here many register as you want. Okay, so you can add either 5, either 10. It's on your choice, but we have to only study about one or three register in A level physics. So what happened is that I connected two register, but I connect here this volt to get how much volt it get passed into this register. So the voltage get start traveling here, and what happens, like, here will be another volt, different volt, and here will be different volt. So if you want to what happened in our uh, like in application process, like you you uh, uh, you put on circuit, and here is bulb. Okay, so it is a bulb, and you want a minimum resistance to pass into your bulb. If you supply the, suppose here is 6 voltage, and bulb has your bulb needs only maximum 3 voltage to light up. So if you provide this 6 voltage, the bulb will get a burst, a boom, you know. But but there is one solution for this. So um, if you wanted to provide only 3 volt into your bulb, you need to put resistance. So here I put two resistance. So why I put two resistance? It means that either I can provide 3 volt, I can either I can provide 3 volts, or I can provide minimum 2 volt. So this is the actual concept of why potential divider is used. So here, um, like I already told you, if you want it, we use this potential divider like in a series resistor, and we'll just put this two connection just at beside the resistor. And what happens that, like, to calculate the volt, the main theme of this is to get how much volt is pass out from this point. So B out, so this is a voltage. B out equals to R2, this resistor, divided by this sum of these two resistor into V in, and you will get the value of how much voltage get passed. So let's do one example here. So this is a circuit, and here is voltage in is 9.0 volt, and here is two resistor R1 and R2 which has 3.0 and 6.0 ohm, and we have to calculate P out. So how do you calculate? We already know that P out is R2 over R1 plus R2 in times P in. So by this formula, we can simply do calculation like 6.0 taking this and 9.0. So the voltage output will be 6 volt. So this bulb require 6.0 volt to light up. So this is not a bulb, not that same bulb that I talk about 3.0 volt. This is different bulb. Okay, so 6.0 volt bulb is sorry, so this bulb needs 6.0 volt to get light up. So this is the simple calculation of potential divider. So I'll show next, the actual potential divider that we see in our real life. So this is the rheostatic potential divider. So this is mostly used in physics lab especially, but we didn't get a chance to use this kind of potential divider uh, while doing practical. So here you can see this is the two input point. Okay, so you can even say like you have to place one wire here positive and here negative, and this is the slide. So suppose this has total resistance, that is let's say 100 kilo ohm. Okay, so let's say this has 100 kilo ohm. So when you place this slide at the middle, it will only provide, like this distance has only 50 kilo ohm. So this has 50 kilo ohm. So it means that this potential divider is used to, like potential means used to provide the minimum this used to provide the required amount of resistance to the source, like light, like you can even say sensor device, so we'll be learning this actual application of potential divider in electrophysics, and it will be one of the most interesting. So this is the actual this is the rheostatic potential divider. So so you can even buy this in a store as you like. So this is the actual phenomena of how this potential uh, divider works. So okay, so before saying, i would like to I'd like to assure you that you subscribe to this YouTube channel, because I'm going to upload one of the interesting video of A-level physics. Okay,